In this video I'm going to show you how I've created an Excel sheet to analyze some data taken for radio frequency power measurements. We're looking to find an experimental value for the exponent, the path loss exponent, which in free space would be 2, but in indoor environments and in urban environments and on the surface of the earth very often differs from that. And it turns out in the hallway we may end up with something actually less than 2, meaning that the signal dies off less slowly. In any case, what I'm going to do is I'm going to start off with my blank spreadsheet here. I'm going to make the cells narrower to get going here, and I'm going to go ahead and make a column labeled R for the distance, and then I'm going to make a column labeled P for power, and this is going to be in dBm units, and then I'm going to go over to another spot and collect some numbers. Well, I got some numbers here, and R is going to then vary from 1 to 5, and I'm going to select that data. I've typed in the first 5 numbers and pull it down, and you can see that it automatically fills that in. Here I've got a bunch of data: -38, -37, -33, -37. I'll take a moment to type this in. -38, -35, -43, -41, -43, -42, -42. I'm almost there. A couple 48s, a 46 and a 5. And finally 3 minus -44 and -44. Okay, so this is my experimental data. Basically, I started taking power measurements as I walked away from the antennas on the ceiling in Donovan Hall, and you can see that it's a pretty noisy measurement, but they do go down. And so what I'm going to do then is first make this into a loss value relative to the power at a distance of R equals 1. Okay, and so I'm going to say that this column is equal to -38 minus what's in that column. So I'm hard coding the -38 in there, and I get a 0. And then if I copy this down, you see that the numbers generally are going positive. And this points out something that may happen in your data, because we want our numbers to basically start at 0 and go up from there. And you can see that we've got a lot of noise here, especially on the first 4 measurements, and I'll show you what that implies. Okay, and so what I'm going to do now is go ahead and plot this data, and I'm in Excel, so I'm going to highlight all 3 columns, select all 3 columns, and click on the somewhere here. I have a chart tool. Boy, insert chart is what I'm going to use, and I'm going to go ahead and insert that chart. I don't think that worked. Okay, so I select my columns and then insert chart. And then I click on scatter, and don't click on line, please. That's not a valid scientific or engineering chart. And what I'm getting here is an X column and then 2 Y columns. And what I can do is I can click on either data set, and I can see that just those columns are highlighted. And so what I'm going to do then is I'm going to save just the loss one, and this other data set, I'm going to go ahead and delete that. Okay, now I have my loss one. But what we're looking for is something that is sort of a diagonal line going up from the origin. And you can see here that I've got so much noise in my first 4 measurements that the origin should really be somewhere else. So what I'm going to do is I'm going to add an offset here. And I'm going to make the offset, I don't know, something like 5. And I'm going to say that this column is equal to the cell to the left plus the cell F3 with $signs on it to fix the absolute referencing. And then I can go to the corner of this cell and double click to copy that down. And then what I want to do is I want to see how this looks, and so I'm going to click on the data series again. And Excel is nice because it allows me to drag this thing that's being plotted around back and forth. And so I can just drag it over to the new column. And you can see now here I've got some data that looks like it might be sort of aiming towards 0 here. And now I'm going to go ahead and next thing I'm going to do is put a logarithmic axis on the horizontal axis. So I'm going to click and double click on my horizontal axis, and I think you can see it here. I'm going to go to the scale and choose logarithmic scale. Okay, so I added that. It's in base 10. So I'm going to see numbers from 1, 10 to 100. Okay, and I'm going to go ahead and get rid of that. And so we see 2. Okay, so now what we've got is more or less a straight line aiming back towards the point 0, 1. And you saw in the theory video that that's what we need. And now I'm going to go ahead and add a theory curve. And I'm going to have a C1 and a C2. And my loss curve is going to be simply C1 times C2 raised, or times the disk R raised to the C1 power. And C1 is F1 with absolute references times the radius raised to the C2 power, which is F2. Okay, and I can double click that. Oh, I can double click that cell, copy it down. And now what I want to do is I want to add this column, this new column, to this plot. And so I'm going to go left click on the data series. Now I'm going to right click, choose select data, and I'm going to go to add a series. And in this series what I'm going to do is I'm going to go back to the first series, and I'm going to take the X values and I'm going to copy that text. Copy. And when I go to the new series I'm going to paste that text in. I'm also going to go back to series 2 and copy the text for the Y values and paste that in here. Except I'm going to change from column F to column G. And now I'll click OK. And in fact, let's see here, my loss is going up too much. I haven't put it into decibel units yet. So I'm going to go ahead and click on the first value and take this and turn it into 10 times log 10 of whatever I had in there previously. Now I'm getting decibel units for that loss, and I can double click on this cell to copy that down. Now I've got something that's looking like what I'm after. And I like for my experimental data to have points and markers, but I like for my theory curve to be continuous, so I'm going to click on it, then right click on it, and click on it with the left. Now I've selected only one point. That's no good. I'm going to click out here. Now I'm going to left click it, select the whole series. Now right click and format that data series and choose marker style to be none, no markers, and line to be a black line with a weight of just 1 point. And I think I better try that again, because now I can't see my data series at all. Oh boy, what did I do? Where's my line? Line. I did the marker line rather than the data line, and I want that to be just a narrow line. Okay, that looks good. 1.5. There we go. And so what I'm going to do now is I'm going to adjust this C2 value, which is our exponent, and try to find the best fit. So I'm going to try 1.5. It looks like I need a lower slope. 1.4, 1.3, 1.2, 1.1. Wow. 1.0. Okay. One thing I can do is I can look at a little RMS difference here. I can say that this is equal to the loss from the theory curve minus the loss, and square that value so it's always positive, and then copy that down and look at the sum equals the sum of that column. I'm going to select those values, and what I can do then is look at this value here and play around with C2 and the offset until I have the lowest possible value there. So 1.2, 1.1 seems like it minimizes it at about 1.1. Oh boy. Okay, let's try this. You know what? I forgot my RMS value is subtracting from the original loss column, not from the new loss column. There we go. Let's copy that down. Yeah, here we go. I think I need a little bit higher slope than that. And you can see here that now 1.2 makes the number go up. Now it's down to 137, and 1.0 makes it go back up again. So 1.1 is a minimum there. 5 makes it go up. 6 brings it down. 7 makes it go back up again. So at least we have some sort of a local. So I'm getting an exponent of 1.1 in that hallway. So I hope this helps in making your data fit. How do I get out of this recording now? Uh-oh. Was it not recording that whole time? Oh, yeah. Huh. I don't know what it did. Where's my recording? Ah.